All right, so we left off last time before the break talking about the this reference variable, which is on the bottom of page 414. Now, I've shown you this kind of thing before, but I'm going to show it to you one more time, and that is this. So if I come through here and I got int age equal 21, all right, and then so that's an instance variable that I've got at the top of my program. I think now everybody understands what instance variables are. All right, then down here, there's some Java code. I don't care what it is. But then down here, I've got a thing where I'm going to be setting the age. So I've got private int, private void, set age, and I pass in int, and I want to use the word age. I want to do that. Again, I've said this to you before. You can't do this. That doesn't do what you might think it will do. That does not take this age that's right here, that is this one. It is that one. But when you put it in like this, it copies it over to itself. That's almost never, if ever, going to be what you want. So if you want to use the same parameter name as the name of the instance variable, you have to put the word this in front of it. Or either do that or change it to a different name. So call it A instead of age. Then you can do that. You can say age equal A. And that'll still work if you say the this dot. And as I mentioned to you, some programmers always put that in there. A lot of this stuff, when you have a choice, it's a matter of personal preference. And I know Micah asked me once with something similar to this, and you said, well, what would you recommend? And it's whatever, and sometimes it is your personal preference, the way that you want to do it. All right? So it's the way that makes the most sense to you. That's what you should be doing. You might go to work for a company that literally, they give you an SOP manual, standard operating procedure, and they say, we do it this way. You know, I think I've told you, when I started at AT&T, they said, do you know C? And I didn't know it when I got hired there, and that's the only language they use. And they said, fine, you are signed up at North Central College in Naperville for a class, right? And I said, no. They said, well, you will be tomorrow. No, they're serious. They paid for it. And I said, why? And they said, Tom Bishop teaches the class. I said, yeah. He works over in the other building. He teaches you AT&T C. That was the best person in the world to learn it from, because it was a guy who worked at the company where he uses it. All right? But that's how they work. You do this way, and somebody says, well, can't you also? No. I don't care if you can do it other ways. This is the way you will do it. But with many of the things in many languages, you have your choice. All right? And I always tell you this, the type of thing that, hey, you know, if you go to get a job someplace and they make you do things a certain way, well, then now you should do it the way you want to do it. That might be the only time. It's kind of like before you get married. You know, you have all that fun, then you get married and you learn what life is actually not fun. All right? All right. You didn't realize you were going to get some free life lessons in here in class today. All right. All right. So as it says, the this reference is simply a name that an object can use to refer to itself. Some languages use the word this. Some languages use the word self. Visual Basic uses the word me. So it depends on the particular language you're using. But they all are talking about some kind of direct or indirect object reference and referring to something regarding the object. All right? So this example is almost identical to the one I just drew up for you. All right? Yeah, this is all fine too. All right. Inner classes. Page 417. So they show you starting on 417, okay, boom, here's a class. And then if you turn up to 418, you'll notice there's another class that starts on line 52. But it's private. So if you have a class within a class, all right, they're called inner classes. The inside one is called the inner class. It's also, you don't see it that often, it's totally legal to have a class within a class, within a class, and there is no limit. If you're going more than 3, 4, or 5 levels deep, you're an idiot. No, you are, because it's going to be very hard for you possibly to work your way out. And that gets to be the case where there's usually a better way of doing it. All right? So notice this. Inner class have unique properties. An outer class can access the public members of an inner class. Anybody can access the public members of any class. All right? An inner class is not visible or accessible to code outside of the outer class. I guess I misspoke. So for the inner class, if you make stuff public, it's available to the outer class, but that's it. And an inner class can access the private members. That's the key one, is the third one. So if I make something private in the outer class, I can access it in the inner class. That's why sometimes people do this. Because a couple of you kind of raised your eyebrows like, why would you ever want to do that? That's one of the reasons. Because sometimes it's easier than doing a lot of parameter passing and the like. All right? And again, it's something you learn. It's something you do or do not, are not comfortable with. That's why, like I said, there's a lot of things when people say, well, you know, in Java, I mean, like, what should I really know? What is important that I learn? All this other stuff. And it's like, it's not anything Java specific. That's why you get a lot of different languages, because you're learning a mindset more than you are. I mean, other than that, any language you go to, it's just syntax. Okay. Inner classes, again, are defined inside of the outer class. Now, notice what happens. When you compile them, it says the file's name is going to be the name of the outer class. So if I had a class outer, and inside of it I had a class inner, then the inner class, when I compiled it, would be called outer$inner.class. All right, and it does that because it's trying to show you that inner is a member of outer. All right, and he gives you an example here with this retail class that's on pages, again, 417, 418, and 419. And if you say, well, that's just really hard to understand, then you aren't going to want to use it right now. There'll come a time when it's actually easier to do that than to do it another way. Not only that, some of the stuff in Java that's set up is literally set up as inner classes. All right, enumerated types I mentioned to you before. There's a good example. Now, there's a few things I want to say about this. First thing is enumerations are available in virtually every language when you create your own data type. That said, they're implemented a little bit different in most every language. Okay? Now, you may or may not understand this. What this says is if I create, notice the enumeration is called day. Then if I create a variable called workday, it's of type day. See that? So the only values it can have are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. That makes sense? Now, that said, the system could care diddly squat about the names of those variables. What it does is it associates an integer with each one of these. So that's 0, 1, 2, 3, 4, 5, and 6. That makes sense? And you go, well, 0 is a dumb name for Sunday. So you could say, for example, right here, you could say Sunday equal 1. Don't put anything in the rest of them, because then they automatically increment by 1. So that would be 1, 2, 3, 4, 5, 6, 7. But the system is more concerned in Java, at least. Now with Swift, which is the new language for writing iOS apps, when you do enumerations, they don't work with numbers like this. They decided not to implement it that way. Java does it more of a standard way that most languages do it, something like this. All right. And I could say, if I wanted to, this would be a silly example, but just so you know it, I could say, for example, Sunday equals 337. If I just put that in there, then that would be 338, 339. You know, I can do that. In fact, I could make that 337, and then this one I could say is equal to 12. And then the next one would be 13. Okay, so you can do that. I don't remember whether or not you can use the same number for them. I don't think you can. All right, well, how do you find out? You write yourself a little program and you try. All right. So as it says, an enum is an example of a specialized class. This is the picture you see on page 421 in the book. All right. Okay, some of the stuff that you can work with enums. This used to be a really important word in computer science, IT, verbiage, ordinal. It's not as important as it used to be. Because in many languages now, when you do a case statement, you can do a case in what you put in there. You can do, when you have your switches or whatever, your selects, whatever it happens to be based on the language, that can be a string. Used to be that you could never do that. It had to be either an integer or it had to be a letter of the alphabet. Because integers and letters of the alphabet are both ordinal. They both have a unique predecessor and they both have a unique successor. What about A? I know A doesn't have a predecessor and Z doesn't have a successor, but you get the idea. Now most languages, when you do case and switch statements, allow you to do them on strings. Okay, so it's not as important as it used to be. So he goes through this example with this demo program for a sports car. And if you do have your book and you want to turn up quickly, it's on 425 and 426, and then the demo for it is on 427. The key thing, though, is what he does. In fact, it starts on the bottom of 424. Is notice, see if he shows it here. Nope, he doesn't, of course. Let's bring that up. I think it's important enough, at least, that you see this if you don't have your book with you. I don't want to waste any more time than I have to. I want to get you done by 11:30. So. Type, car color, sports car. First of all, take a look at this. Let's start with this one. That look funny to you? There's no main. There's no nothing. That's a Java file. That's a Java file that holds an enumeration. That says that you can go in and you can build yourself. You can create a variable that's called car color in your program if you include this enumeration. And that car color can only have those values. So your car can be red, black, blue, or silver. All right. There's your types. Kind of nice. All right. Then when you get in and you look at the sports car, notice what it says. Private car type. That car type is this. All right, then it says, somewhere in here, there's color. Car color. And that's this. And you can do that as long as you include those two files inside of your package where you have everything else. You know how to do that. All right. And they compile along with the rest of your program when you compile the program. All right. Why people sometimes use these is shown in here. No, it's not. All right, shown in the, is it, okay, where is it? It's in one of these. There. Your code becomes a little bit more readable. So instead of saying case 1, case 2, etc., people oftentimes do this. Think about a program that was days of the week, and you wanted to be able to say Friday, woohoo, or Saturday or Sunday, it's the weekend, Wednesday, it's hump day, that kind of thing. All right, you make your program a little bit more self-documenting. All right, you can get along fine without ever using these, but a lot of people like to use them. Garbage collection I already mentioned to you. I'll just leave it up there for a second, take a sip of my drink, and you can see it. If you look at that last bullet, when you don't need a variable anymore, you set it equal to null. And that sends a signal out to the system that it's not needed any longer. All right, and I think I showed you this way back near the beginning of the semester, but I'm just going to put it up here one more time so at least you see it. And that is that you can come and type in this. That's calling the garbage collector. System.gc. You can put that anywhere you want in your program. What that is doing is requesting that the garbage collector be run. You can't force the garbage collector to run. It's an operating system process, and it's so low on the list of processes that you can't force it. But what you're doing is you're sending a signal to the operating system. Hey, next time you got some free time, come over here and clean up memory for me. All right. All right. The garbage collection is mentioned here as part of the JVM, the Java Virtual Machine. you may or may not know this, but so far this semester, you've been using everybody in here in the C# class, right? So you've been, well, just about. All right. But you're in C#, you've been using something that you probably never even heard this acronym before. It's the CLR. All right. The CLR is the Common Language Runtime. It's the thing that works behind the scenes to make your programs work. The equivalent in Java of the CLR is the JVM. Okay. So he goes a little nuts here with his garbage collection stuff. It's all fine. Finally, he says this. Okay. Now I'm going to tell you something that you may or may not have known. You know there's a constructor. You know how to write it. But it is also possible for you to write, for any time you write a program, you can write a destructor. Virtually 100% of the time, no one ever does it. And the reason you don't write a destructor is you have no control over when the destructor is called. So instead of writing a destructor, what most people do is they write a finalize method. What do you want to do there? Well, you want to make sure if you've got a database open that you close it. Files that are open, you close. Any resources that aren't yours that you're using, you close them or give them up. All right. So they talk about finalize in the book here on the bottom of page 430. Then the chapter ends with talking about, I'll show you that real quick. There it is. That's a CRC card. Okay, CRC stands for Classes, Responsibilities, Collaboration. What you do is you take an index card, and on the top you put a line through it like this. That's the name of your class. All right? These are its responsibilities. So, in other words, those are going to basically end up becoming the methods. These are what the methods are going to have to interact with. Quite often what people end up doing is they create these before they've even started doing any coding. And they talk with other people that, you know, when they know their objects are going to be communicating with one another to say, hey, this is how I envision things. All right? Before we've ever started a new program here, we get a meeting of our advisory committee together. And we spitball. Literally, they say, well, if we had a new program that did this, what would you want it to do? And people could say anything they want, even if it's really kind of weird. And somebody's got a list of Post-it notes, and they put them on a wall. Then they start taking all the stuff and they say, okay, well, we got this and this. They're really the same thing. So they throw out the ones that aren't the same thing. And they group together the things that seem to belong together. Then they prioritize. That's basically what you're doing right here. All right? And that's it. So very quickly, just one more time so you see it. Alright, so your next assignment, it'll be lab all week next week. Your next assignment, your homework for Chapter 6, alright, will be that month one we've already done and the geometry one. I'm going to show you a run of my geometry program in just a second. Alright, but those are the two. Again, it'll be lab next week. I did fill out my form. I hope my boss signs off on it, but absence of duty form that I did ask off for 2 weeks from today. Alright, I got an email asking me whether or not I was going to be able to make it. Mom's 85 and she's on Facebook. Yes. Not often, but she's on Facebook. So. All right. Yes. That's what it is. Yes. No. No. Yes. Yes. But you wouldn't put main in a class by itself like we've been doing. That's not the way you'd do it. You would do it because you would have similar functionality where one thing would maybe even be a part of another. That's typically the way that it's done. Okay? Now, you want to leave, you can leave, but I'll still be done right around 11:30. And what I want to show you is I'm very quickly going to do a run of my geometry program. All right? The geometry program, the one that you're going to be doing, is on the bottom. It's on page, I don't know what page it's on. It's on the bottom of page 445 and the top of 446. Originally, I'd given you an employee one for this, but we already did that. You already did it. I'm dumb, but I'm not totally stupid. All right? So, the one that you're going to do, I'll just show you a run of mine. I got a demo. I'll just run the demo here. Yes, that's not an April Fool's. Again, since I won't be here on that day, I won't be grading until that Friday. All right. Yeah, you always do. Even when I say they're due Wednesday, I typically grade them on Friday. So that's not a problem. I told you, John, I have way too many programs in this folder. So, all right, can everybody see up on the screen here? You're going to have something that looks like this. This is the same thing that they show in the book as far as the menu on the middle of page 446. It looks almost like exactly like it. So, I type in a 1. Means I want a circle. What's a circle's radius? 100. All right, it's 31, 415.93. Okay, that type of an idea, unless I did the math wrong. Number 2, it's a rectangle. What's its length? 10. What's its width? 20. 10 times 20 is 200, right? All right. 3, triangle. What's its base? 34. I think this would, I don't remember if you got to use the Pythagorean theorem here or not. I always forget, so we'll try it. 10, 5. Okay, so the area is, okay, it's 1/2 the base times the height, so that's 25. Notice if I put in something that's not a 1, 2, 3, or 4, 55, just says error, tells you to enter 1, 2, 3, or 4. All right, and 4 quits the program. You don't have to say goodbye, but you're more than welcome to if you want to. All right, all the instructions for this, it says design a geometry class with the following methods. I didn't like any of the programs in this chapter. The only one I liked is the one we did as a class. All right, so this is the one I figured would be probably the easiest. It's a little bit challenging, but still probably the easiest for you to do. If you start on it today, I wouldn't be surprised if you'd finish it today. All right, that's all that I got. I took a minute extra.